Ages of star clusters using HR diagrams. Recall that when we are looking at a star cluster, what we are seeing is a group of stars that are the same age. But because they are different masses, they're going to die at a different rate. So you're going to have low mass stars that will either still be forming or at least still main sequence, versus high mass stars which will have probably already died. So what we can do is use an HR diagram to see all these different stages, because we can have within the HR diagram a region of forming stars, main sequence stars, dying stars. So where we see giants, dying stars, main sequence, forming stars, which of these we see is going to tell us how old that cluster is. So what we're going to look for is called the turnoff point, or top for short, because where they leave the main sequence means these stars have died. And so what we're looking for is what's the lowest mass that has died and how long do those stars live? Because, of course, the lower the mass, the longer they live. So the lowest masses that have died tell us then how long this cluster has been around. And so by knowing their lifespan, we can figure out the age of the cluster. So let's look at some examples of what this would look like for different ages of clusters. So here we see an example for a young cluster. So if it's young, only our high mass stars have died. So if we look here, we probably would also have some up here, because these would still be protostars for our lowest mass. So our lowest mass stars are probably still protostars, not even on the main sequence. Our medium mass are going to be on the main sequence. And it's only our highest mass that has died. So it has left the main sequence. So our turnoff point here is very high on the main sequence, meaning it's near this upper part of the main sequence. So this is a high turnoff point. If the cluster is a little bit older, then we've got our lowest mass are now main sequence. But now we're starting to have both medium and high mass have died. So we don't see anything on this part of the main sequence. We have turned off partway down. So now we're dealing with a medium-aged cluster because our turnoff point is lower on the main sequence. And then finally, for the very oldest cluster, only the low mass stars are on the main sequence. All the other stars have died. So now our turnoff point is very low. It's near almost the bottom of our main sequence line. So our main sequence line is that general relationship between brightness and temperature. And so now we're to the point where almost none of the stars in the cluster are main sequence anymore. Almost all of them have died. So we are looking at a very, very old cluster in this case. So with clusters, because they are all the same age, we can plot them all on one HR diagram, and from that determine how old that cluster is based on which stars are still main sequence and which stars are no longer on the main sequence. And that gives us the age.